this is the same as this. I'll stick with modern agricultural corn, thank you very much. So, how are these seemingly different organisms the same thing? Well, that's all thanks to us humans making things I mean, artificial selection. It's not just this either. All kinds of modern crops, ornamentals, and pets have been selectively bred by humans for thousands of years to arrive at something that benefits us. But just what does it mean when I say artificial selection? Well, artificial selection or selective breeding is when you choose traits in another organism that we find the most desirable. And then we take two individuals with the same traits to result in that trait being more prominent in the next generation. Using my corn example from earlier, we found that there are some corn plants in nature that had bigger kernels with more kernels per stalk and more ears on a single plant. Then we would take the plants with those same kind of traits and make sure that over time they were the plants that were producing offspring and the ones that we were using for agriculture. Over many generations, we arrive at the corn we have today in our fields. Selective breeding and artificial selection have been practiced for thousands of years, way before we actually knew why it worked. We just did it because we knew it did work. For instance, we have documents from 2,000 years ago instructing farmers on how to remove undesirable corn from your fields to ensure that better corn popped up in the following season. A real understanding of why it works didn't come about until Gregor Mendel, a European monk who did some experiments with peas in the 1860s. He monitored changes in offspring based on the traits of the parents, such as flower color. He noticed that some traits were more likely to be shown in offspring, and they became the dominant traits. Similarly, some traits didn't readily get passed on, and so these are recessive. Some traits still got mixed together, like if a white and a red-flowered parent produced offspring, it would be pink. From these experiments, he theorized that there was something being passed through generations, calling them alleles. Nowadays, we know that the information within the alleles is DNA, and that the differences in genotype and alleles of DNA results in a change in phenotype or physical appearance. It's amazing to me that we were able to successfully cultivate so many organisms without really understanding what the mechanism was and why it worked. Now, something to note is that we're not really making new species when we're artificially selecting. We're just producing what is known as cultivars. Perhaps given enough time, they'd become new species, but given the time frame where we are working with these organisms, the plants themselves can still crossbreed. This can result in some really cool stuff, like the production of cauliflower. If we cross a mustard plant with enhanced flower development and suppression of the flower's growth itself, it can result in sterility of the flowers and those white heads that we get. In fact, wild mustard has resulted in all kinds of cool crops, like broccoli, cabbage, kale, Brussels sprouts, and kohlrabi. These are all just from one plant. This is true for animals too. Dogs are just Canis lupus, the gray wolf, artificially selected for thousands of years. House cats too. They're all domesticated from the Felis sylvestris wildcat. Like, this? Is this? Is this? Is this? Is this? Genetics is nuts. Artificial selection isn't always the right move though. Sometimes the traits that we want are linked to undesirable traits. We've seen this a lot with dogs these days. For instance, in the German Shepherd, as we select for broad-shouldered, highly muscular dogs, it impacts their hips and back, resulting in physiological challenges when they grow older. This has happened with plants as well. All plants naturally produce toxins to defend themselves, and sometimes we select for those traits to make sure that the plant can naturally defend themselves against pests. However, if we select for those traits too much, we can make the plant itself more toxic to us. This happened with tomato plants in the 1950s. We selected for the toxins in tomatoes just slightly too much, meaning when we concentrated them into ketchup, we made a ketchup that was toxic to us. This ended up making a lot of people pretty sick. Modern technology has sped up the process of selectivity for desired traits even faster via GMOs. And I did a video on that. Link in the description if you want to watch. And in conclusion, I'll leave you with this. More and more, we're learning that we're not the only organisms on the planet to selectively breed organisms. Ants have been artificially selecting for the desired traits in the fungi that they cultivate for hundreds of thousands of years. Not only that, but ants might be artificially selecting for traits in themselves. One explanation for why there are so many different kinds of workers in a single colony of ants is because the ants curate and pick traits that are beneficial for the colony when developing, and they ensure that subsequent queens harbor more of those traits for those worker castes.
Explosion.
As always, I want to hear from you. Are any of you avid gardeners? Know anyone that selectively breeds? And what do you think about the new intro that I have for the videos? Let me know in the comments below. Thank you all so much for watching. If you liked what you heard here, please hit the like button. If you want to see more, subscribe. And if you want to see more of my furry antics, follow me on Twitter. I hope you all enjoyed this episode and know a little bit more about what you eat and your pets. Until next time, love you all and see you later.